Okay, so what we're doing for today, we are discussing multiplication and division of our rational numbers. So we're focusing today mainly on contextual problems, word problems. So we need to focus on those key vocab words that will emphasize whether we're dealing with a multiplication problem or whether we're dealing with a division problem. And we're also going to discuss how we go about converting from fractions to decimals using our division. Okay, so we're going to start off first with multiplication. So multiplication has some pretty basic key terminologies that are written here. We've got the words obvious, like multiply. That's an obvious one. Times is a quite obvious one as well. Product doesn't just mean multiplication, but it means it's the answer to multiplication. That's one of the things I want you to put down, that this is the answer to multiplication. So when I say that you're taking the product of something, I mean that you are finding the answer to a multiplication problem between these two values. Okay, we also have the term by. We also have area. Area is a big focus. Usually when we focus on area, that's a multiplication problem. Then we have a couple of words that actually reference specific values you're multiplying by. So if I say double, what are we multiplying by? Times 2, right? If we say double, we're multiplying by 2. What if we say triple? What are we multiplying by? 3. Timesing it by 3. If we say twice, what are we multiplying by? 2. Okay, so double and twice can also mean the same thing, timesing it by 2. Now, there's a couple of things that I did not put up here that you do want to make sure you have a good focus on. Fraction of something. The term of, when we're talking about rational operations, term of actually means that you're multiplying. So if you ever see a problem where you have a fraction and then the word of and then something else that it's relating to, like if I say 2/3 of the class has finished already, then that means I would be taking 2/3 and I would multiply it by the number of people in the class. Okay, so if there's like 24 people in this class, multiplying that by 2/3, then we're talking about 16 people being done. Okay, so whenever you see a fraction and then it's followed directly by the word of and then something else, and that something actually does have a quantity to it somewhere else in the problem, then you know that that's going to be multiplication. Fraction of something. Okay? Another key phrase or words that you need to look for. If you see the words per, each, or every, you see the words per, each, or every in the problem, not the question. It's in the problem, not the question. Then that is also going to reference multiplication. Per, each, and every are key phrases or words that would reference a multiplication problem as long as the word per, each, or every is not inside the actual question. If it's just inside the problem itself, if I say, oh, Ava gave 5 sticks of gum to every kid in the class, and there's 20 kids in the class, then how many sticks of gum did she give? Then we know that that's multiplication because we had the term every. She gave this to every kid in the class. Now that would be different if the question said, hey, Ava gave out 100 sticks of gum to students in the class, and there are 20 students in the class. How much gum did each student get? Or how much gum did every student get? Or how much gum per student? That's when it's in the question, and that becomes a division problem. So let's look over at division. Okay, with division, again, like I said, per, each, or every, but this time it's going to be inside of the question. Per, each, or every if it is inside the question. Okay, when you see the terms per, each, or every inside of the actual question being asked, then that's a division problem. Okay, and then we have our basic ideas of, if we see the words divide, we know that that obviously is going to be a division problem. How much does it go into? That's a division problem. Division basically breaks things up into those equal parts. So if you're talking about having things being shared equally or split equally, that's going to be a division problem. Ratios, like fractions, those are actually division problems right there. And then just like product was the answer to a multiplication problem, quotient is the answer to division. Okay, the quotient is the answer to a division problem. And then if I say I'm taking half of something, what does that mean? We're dividing by. We're dividing by 2. If I take a quarter of something, we would be dividing by 4. If I take a third of something, we're dividing by 3. That kind of thing. Okay? All right, so what we're going to do right now, and you can do this with your group, is you are going to highlight things very carefully. You're going to need all 4 colors, well, not all 4, because there's 5 colors, but you're going to need blue and orange to highlight key words or phrases that are indicating multiplication or division within inside the problem. And then you're going to want your pink and green highlighters. Green to highlight if we are talking about a positive integer, pink to highlight if you're talking about a negative integer. And one thing I want to make sure that you understand, and write this up at the top, if we are talking about people and time, the concept of a person and the concept of time, what kind of integers do you think that those are always going to be? Positive, right? You can't have a negative amount of people. You can have a negative person. They have a negative personality, but you can't have, yeah, Tanner's like me. That would make you positive then because you were so proud of it. So you can't have a negative amount of people, and you can't have a negative amount of time. So when we're talking about people and we're talking about time, you're not going to see positive or negative words around them, but you'll see that they're a person, or you'll see that it's time, and automatically you can assume that it's positive. So people and time are always positive. All right. So again, with your table, you're going to go through each problem. You're going to go through each problem. You're going to highlight the values as a positive in green, as a negative in pink. You should have 2 values that you're highlighting. Some of them might be both positive, some might be both negative, one might be positive, one might be negative. And then you're going to highlight the word or phrase that's indicating multiplication or division. Multiplication in blue, division in orange. Going to give you until we go to lunch. Let's take a look at problem number 1. Shh, quiet down. Problem number 1, you should have highlighted in pink that there's an overdraw of negative 25. That's $25. Overdraw is a negative term. That means you are drawing too much money out of your account that you do not have. In green, I'm going to go ahead and highlight the term 4 days because that is a positive, because remember, days are always going to be positive. And then I'm going to go ahead and highlight the term every, and it's inside the problem and not within the question, so that means we're going to go ahead and multiply. And we're going to get negative $100. Okay, for problem number 2, Alex's team lost a total of 54 yards. That is a negative term, so we're going to put negative 54. There's 9 players on the team, so those 9 players is going to count as a positive. And then we are going to go ahead and divide, because there's 2 things that you could have identified. The fact that they're saying that all the players lost the same amount, which means that we are going to be splitting it equally. Or you could have even identified that there is the word each inside of the question. So you could put division here. So that would be becoming a negative 6. So negative 6 points for each player. For problem number 3, the temperature falls 3 degrees. That's going to be a negative. And it's going to do this for a period of 8 hours. That's a positive. So we know that we're dealing with a -3 and a +8. And it says it's going to do this each hour. That is inside of the question, inside of the problem, each. So we're going to go ahead and multiply. That means that we're going to have a total degree drop of -24 degrees. For problem number 4, a submarine dives. That's going to be a negative, dives 20 meters. It's going to do that for a period of 15 minutes. And we have the term each, again, inside of the problem, not the question, but in the problem. So that means we're going to do -20, and we're going to multiply it by 15 minutes. And that means we're going to have a total drop, or a total change of -300 meters. Okay, go ahead and flip it to the next page. We've got problems 5 through 10. And again, if you don't have this all down, that's fine. You can go ahead and get it down later. This is being recorded. It will get posted into Google Classroom. Okay? All right, taking a look here. Matt lost 24 pounds in 8 weeks. So lost is a -24 over a period of 8 weeks. That is a positive for 8. And then the question was asking, what was his average change per week? Per week. That's a division problem. So we're going to go ahead and divide. So the average change or average amount that he lost is 3 pounds. -3 pounds per week. Okay, Keither borrowed $4 a day until he had borrowed a total of $88. For how many days did he borrow the money? Okay, so we have a double amount of borrowed, right? He borrowed $4 a day until he borrowed a total of $88 a day. How many days did he borrow that money? Okay, so the question itself is kind of breaking it down into equal parts. If you're trying to figure out the number of days, you're splitting the money up amongst the number of days. So that means you're taking -88 and you are going to divide it by -4. And that's going to give you a positive 22 days. All right, for problem number 7, Derek and Anita each made a bowl of punch. Derek made 3/4 a gallon. Anita made 4.5 times as much. 4.5 times as much. Okay, so he's making a certain amount. She's making a certain amount. The amount that they make is a positive amount each. And then we're multiplying it by 4 times as much. 4 times as much. So you're just multiplying these values together. 3/4 multiplied by 4.5. And that's going to come out to 3 3/8. Okay, at the end of the night, a pizza place had 2/3 of a pizza left over. 4 of the employees each took home an equal amount. How much did they each get? So 2/3 of the pizza, that's a positive. There's 4 employees, that's a positive. And they each are going to take home an equal amount. So I know I have a keyword each here, but I also have the word each in the question. That trumps this each. Okay? That overrides this each, especially since they also says that each was going to be an equal amount. So there's our question. We're going to take the pizza, God bless, we're going to take that 2/3 and we're going to divide it equally amongst the 4 people. And that means each person's going to get 1/6 of a pizza. Okay, a sandwich is 4 3/4 inches long. Mary eats 3/4 of the sandwich. So we're given a measurement for the sandwich, 4 3/4 inches. She's going to eat 3/4 of it. When you eat them, that's also positive, but it's 3/4 of the sandwich. So remember when I said of an amount, so a fraction of an amount. We have a fraction of an amount. That means it's going to be multiplication. So you are taking 4 3/4 and multiplying it by 3/4. And that's going to come out to 3 9/16. A painter has 16 3/5 pints of paint. He needs to paint 4 1/5 rooms. How much paint is he using in each room? Okay, so again, how much is he going to use in each room? That's going to be a division problem. Okay, the amount of paint that he has, both of those are going to be positive values. So we're going to take the amount of paint that he's got and we're going to divide it equally amongst the 4 1/5 rooms that he's going to have. That comes out to 3 20 over 21. Okay, the important thing is that you guys at least know what is going to be the operation in these problems. I think you guys are fine when it comes down to identifying what type of number you're dealing with, whether it's a positive or negative. I think that operation is the most important thing for you guys right now. Okay, go ahead and flip it to the next page. All right. Actually, you know what? I think we're going to run out of time. So I want to go ahead, just skip this page. Go to the last one I have here. Go to fractions, or division problem decimals. I want to make sure that we're able to go through this. Okay, because this is really, really important for you guys to understand. A lot of people mess up on this when they're trying to identify, you know, which one of these fractions is not like the others. So when you're looking here, I have a negative 3/5, I have a negative 3 over 5, I have a 3 over negative 5, and then I have a negative 3 over negative 5. One of these is not like the other. Which one do you think is not like the other? A, B, C, or D? I want you to discuss with your table. If I were to label these A, B, C, and D, which one of these is not like the rest? All right, give me a thumbs up if you think the first one, A, is not like the others. Thumbs up. What about B is not like the others? C is not like the others. D is not like the others. Okay, D is the one that's not like the others. Here's why. If you take a look, the first three, these first three are all considered to be negative rational values. These are all negative rational values. The last one, though, is a positive. Why is it a positive? Why is it a positive? Because you have both of them a negative, right? If you have a negative over a negative, what's a negative divided by a negative? A positive. Okay? So when we're looking here, it's perfectly fine that you've got one negative sign in the front. The way that this looks as a division problem, it's like you're dividing 3 and 5, and then you've got a negative in front of it, in parentheses. Okay? So that comes out to a negative 0.6. Okay? When you've got negative 3 over 5, then that's just a negative 3 divided by 5. That's, again, negative 0.6. When you got 3 over negative 5, then that means you're doing 3 divided by negative 5. That, again, is still a negative 0.6. The only one that's coming out to that positive is the one that's having the double negative. So when you've got a negative 3 divided by a negative 5, that's going to come out to a positive 0.6. So this one right here is the only one that is not like the rest because of the fact that it has that positive. The rest of them all have a negative sign as their part of their answer. Because again, they all only have one negative within inside of their fraction. They have just one negative. The minute that you have two negatives, it changes the result. Okay? Same thing would happen for here as well, except this is going to be a repeated. In fact, to make it an easier one, go ahead and change those 7s to 6s. Oh, dear God. Seriously? I thought that was so last year. God. That is so last year. Come up with new material. Okay? All right. So we've got 2 over negative 6. We've got negative 2 over negative 6. A negative 2 over 6. And then negative 2 over 6. So with these ones, again, when you're taking a look here, They each only have, these ones right here that I'm writing down, each only, oh sorry, that was supposed to be a 6. These were only a single negative that we were focusing on, which this would come out to a negative 0.3, but it would repeat. So if I'm showing that it repeats, what do I need to put? The bar. Does anybody know what that's called? The thingy on top. The bar on top is called bar notation. Bar notation indicates that you've got a repeat going. So negative 0.3. All of these ones are going to come out to negative 0.3 repeated, bar notation, except for this second one. Because of the fact that we have that double negative, a negative 2 divided by a negative 6 comes out to a positive 0.3. So again, those double negatives are what's going to throw you off. If you only have one negative, the answer is negative. If you have double negatives inside of the fraction, then the answer is positive. All right, you were not able to get to the mystery puzzle, but that's okay. You can get to it tomorrow. It'll be the first thing that you're going to work on tomorrow, and then you can get to the IXLs. Remember, substitute. Be on your absolute best behavior. You get to listen to music, but you need to be on your absolute best behavior.